Hello, welcome to today's math class. Today we have this math related question before us here. The question says solve x to the power of 2 minus x to the power of 3 equal to 150. We can solve this math challenge using two different approaches. How? We can move this term to this side and move this to this side, then bring this to this side. In order for this to have a positive sign, then this have a negative sign. Then take this back again to give us our positive sign. In other words, to give us our x to the power of 3 minus x to the power of 2 plus 150. That is one of the ways of solving this math challenge. But yeah, we're going to solve it the way it is now. How? Let's take a solution. If you are new to this math channel, this is Math Pros. Subscribe. And when you subscribe, do not forget to turn on the bell notification button because that is the only ground you get notified whenever we drop an amazing video. Because here we drop videos all the time for our learning. Alright, so now let's take this question the way it is. So we're going to have our x to the power of 2 minus x to the power of 3. Then move this quantity to the left hand side. This will give us minus 150. Easy. Now look at the power we have here. We are having 2 and here we are having 3. So we split 150 into two numbers whereby it's going to give us a particular number to the power of 2, then minus a particular number to the power of 3. Yes, we can split this into 25 and 125, right? Then how? Just rewriting this is going to give us our x to the power of 2 minus x to the power of 3, then minus 25, then minus 125, everything equal to 0. This is equal to 0, please. Okay, we know 25 can be expressed as 5 to the power of 2 and 125 can be expressed as 5 to the power of 3. True or false? True. And so this is going to give us our x to the power of 2 minus x to the power of 3, then minus 5 to the power of 2 minus 5 to the power of 3 equal to 0. Easy, right? Now we want to do some rearrangement. We want to marry this that is raised to the power of 2 with this that is raised to the power of 2, and this to the power of 3 with this that is raised to the power of 3. And so this is going to give us x to the power of 2 minus 5 to the power of 2 minus x to the power of 3 minus 5 to the power of 3. This is equal to 0. Easy. So we can put this and this in bracket. So this will give us s to the power of 2 minus 5 to the power of 2, all in bracket, then minus bracket x to the power of 3. Automatically, if we use this to multiply this, this will give us plus. So this is going to give us plus 5 to the power of 3 close bracket. This is equal to 0. But if we use this to open this, it's going to give us this back, right? Good. Now, here we have s to the power of 2 minus 5 to the power of 2. What comes to mind is what we call difference of 2 squared. You remember that? Difference of 2 squared says that if you have your a to the power of 2 minus b to the power of 2, this is equal to a plus b, or in bracket, a minus b, close bracket. Now, inside the second bracket, we are having x to the power of 3 plus 5 to the power of 3. So what comes to mind is sum of two cubes. And what does it say? It says that if you have your a to the power of 3 there plus your b to the power of 3, this is equal to bracket open your a plus your b close bracket, your a to the power of 2 minus your a b plus your b squared close bracket. Now we're going to apply these two rules in solving this expression in here. So if we rewrite this and this in this format, then we're going to have something like this. So this now implies our x plus our 5 bracket bracket x minus 5 close bracket, then minus, here we're going to have our x plus 5 close bracket, then bracket our x to the power of 2 minus 5x plus our 5 to the power of 2 close bracket. This is equal to 0. Are we getting something from here? Good. If we're getting value from this procedure, give this video a thumbs up and also do not forget to subscribe. Now, what do we do now? Look at what we have here. We are having x plus 5. Here we are having x plus 5. So we can easily factor out x plus 5 from the system. So if we do that, it's going to give us x plus 5 close bracket, then bracket. If we use this to divide this, we are left with our x minus 5. Let's put this in bracket, then minus 6. We use this to divide this will leave. So we are left with this. So we now have here bracket x to the power of 2 minus 5x plus, it will give us 25 close bracket, everything equal to 0. Let's include our square bracket here. Alright, now we can now go ahead and open up this bracket here. So we're going to have here to be x plus our 5 close bracket, then bracket our x minus 5 minus x to the power of 2 plus 5x minus 25 close bracket equal to 0. Easy, right? So we can just rearrange by calculating terms that are same here. So this will give us our x plus our 5 close bracket, then bracket. Let's take this first. So this is going to give us minus x to the power of 2. Then we come to the x term. So we have x plus 5x will give us plus 6x. Then we have minus 5 minus 25 will give us minus 30. So bracket, everything equal to 0. So what comes to mind, we can apply the rule which says that if you have your A times B equal to 0, this means that your A is either equal to 0 or B equal to 0. So if we apply this rule called zero product rule, then we have two cases here. We can equate this to 0, equate this to 0. So let's take case 1. Case 1. So what is it going to give us? So we're going to have here x plus our 5 is equal to our 0. So send this to this side, is going to give us x1 is equal to minus 5. Wow. So this is the first value of our x in this equation. So we take our second case scenario. From here, we now have our case 2. So what is our case 2? Our case 2 reads that our minus x to the power of 2 then plus 6x minus 30 equal to 0. Okay, now we want to eliminate this minus sign we have in here now. So we multiply through by minus 1. So if we multiply through by minus 1, it's going to give us here our x to the power of 2, then minus 6x, then plus our 30 equal to 0. Now this is a quadratic equation. So how do we solve this quadratically? And again, here, because it's a quadratic equation, we have to solve for two good roots from this challenge here now. Now, if you look at this challenge, we cannot use the factorization method. So we want to resolve to what we call the formula method. So using the formula method, we're going to have here our x is equal to minus b plus minus the square root of our b squared minus 4ac, everything all over 2a, right? Then we bring out the value of a is equal to the coefficient of x squared, which is 1. Our b is equal to minus 6, and our c is the constant term, which is positive 30. So substituting this now implies our x is equal to minus bracket minus 6 close bracket plus minus the square root of our minus 6 all to the power of 2 minus 4 bracket 1 bracket 30 close bracket. And this is all over our 2 into 1. Good. From here, we're going to have this to be positive 6 plus minus the square root of 36 minus 4 times 30 will give us 120, right? Everything all over 2 because we have 2 times 1 here will give us what? 2. So we are now having 36 minus 120, and 36 minus 120 will give us minus 48. So this will now give us here 6 plus minus the square root of minus 84, right? 84 rather, yeah. To give us minus 84 all over our 2. Okay, now let's look at 84. We can split 84 into a system that will give us something useful. How? 84 can be split into 4 times 21. And we have a minus sign here. And so times minus 1. So we have this to be 6 plus minus square root of minus 1 times our 4 times 21. Everything all over 2. Are we learning something here? Good. We know that the square root of minus 1 is equal to I. So we can bring that in here. And the square root of 4 will give us 2. And so we're going to end up having 6 plus minus our 2I into the square root of 21. Everything all over 2. Now, because we can factor out 2 from here and we have 2 at the denominator, so let's go ahead and factor out 2 from the system here. So this is going to give us here our 2 into 2 into 6 will give us 3 plus minus our, if we use 2 to divide this, we are left with just I then into the square root of 21 close bracket all over 2 here. So we can use this to divide this. And so we end up having our 3 plus I into the square root of 21. So here we have two roots to this part of it. So we're going to have our x2 is equal to our 3 plus I root 21, and our x3 is equal to 3 minus I root 21. Remember, we solved for our x1 already, which is this minus 5 here. All right, so therefore, in all, we can say, therefore, our x is equal to, we have a minus 5, comma, then 3 plus I root 21 here, comma, then 3 minus I root 21 again. So these are the three value or roots to our x that satisfy these math Olympiad challenge. So if you've learned something from this video tutorial so far, then give the video a thumbs up. And if you're not clear with any of the steps I apply in solving this math challenge, drop it in the comment section. Or you have a better way of solving this math challenge, also share with us. Thank you for watching Math Prowess. Bye.